Hey guys, today we're going to be looking at some more examples of graphing trigonometric graphs, so your sine and your cosine functions, when there is an amplitude and a period change. So we are going to get really good at graphing the most basic sine function and the most basic cosine function. Like you should be able to graph just y equals cosine of x as well as y equals sine of x first, because that's how you have to start any of the transformation problems anyway. Remember, sine and cosine have a normal period of 1, which means they only normally go up to 1 and down to -1. And they have a normal period of 2 pi, which means that their one wavelength or one period fits between 0 and 2 pi. So with this problem, instead, we don't have a just regular sine function. We have a couple of different numbers that are thrown in there. So the amplitude for a sine or cosine function is affected by the number that's multiplying out front. It's the absolute value of that number. So the amplitude of this function is actually going to be 2. And the period of this function, the normal period is 2 pi, so we do 2 pi divided by whatever number is inside of your sine or cosine function that's multiplying the x. So 2 pi divided by 2, and then that actually reduces to just pi. And so visually, let's talk about what this will do to your graph. So our normal, before we actually draw it, or draw it out more accurately. We'll just do a quick sketch. So a normal sine function normally goes up to 1, comes down, comes back up to 0. And so this amplitude change is going to stretch our sine function so that it goes higher and lower, right? Instead of the amplitude only going up 1 or down 1, it'll go up 2 and down 2. So that's what the amplitude change will do. And then our period change will take our sine function, our normal sine function, usually fits between 0 and 2 pi. So that's this length to here. And the period change means that instead of fitting between 0 and 2 pi, it's now going to fit between 0 and pi. So I'm going to take this graph and it's going to fit and be like in half of the distance instead. So one wavelength is all of a sudden going to shrink so that it fits between 0 and pi instead. Before we go ahead and get started graphing the different steps of these, I'm going to fill out my table. So we have, these are all of the original x-coordinates on our original function. So these are the 5 main x-coordinates you'll be using to graph just the most basic sine and cosine functions. So we have 2 pi, pi, pi over 2, 3 pi over 2. And a normal sine function starts, and then we have to have our y-axis as well, so 1 and -1. Our normal sine function starts at the origin at pi over 2, it goes up to 1, pi, it goes back down to 0, 3 pi over 2, it's at -1, and then at 2 pi, it's back at 0. So this is the original sine function, and so I usually label that so that way when I start to apply my different transformations, I don't get mixed up on which one's which. And I'm going to do my period change first, so I'm going to take each of my original x-coordinates, the ones that are already listed on here, and divide them by my k, which is the number that you used earlier to find out your final period. So I'm going to take all of these x-coordinates and divide them by 2. So 0 divided by 2, luckily for us, is still 0. When you do pi over 2 divided by 2, I'm going to run out of space a little bit there. Let's see if I can zoom in. There you go. All right, so when we do pi over 2 divided by 2, this is a fraction inside of a fraction, so how we deal with that is we take our bottom piece, so our bottom part of the fraction, and I'm going to flip and multiply it instead. So it becomes, instead of doing pi over 2 divided by 2, I'm going to do pi over 2 times 1/2 instead. And so then I'll end up with pi on top, because pi times 1 is pi, and then on the bottom, 2 times 2 is 4. So that would be where my new x-coordinate is at. 0 stayed at 0, pi over 2 is going to move to pi over 4. I'm going to continue dividing each of these coordinates by 2. So pi divided by 2 is just pi over 2, so that's easy. 3 pi over 2 divided by 2, I think I'm going to have to do a little bit of flipping and multiplying here as well. So I'll take my bottom number, flip it so it becomes times 1/2 instead. And I'll end up with 3 pi times 1 is 3 pi. 2 times 2 is 4. So my 3 pi, my coordinate that's at 3 pi over 2 will move to 3 pi over 4. And then last but not least, I do 2 pi divided by 2, and your 2's cancel, and I'm left with just pi. And again, if at the very end, this piece down here should match with what you found up here. So that's how you know you've ended it correctly at least. All right, so what I'm going to do is I'm going to take my points that are at each of these x-coordinates and I'm going to move them. I'm going to shift them so it squishes my whole graph so they end up now at each of these x-coordinates instead. I'm not going to move them up or down at all. I'm literally just going to move them to the left so it squishes my graph. Okay, so my point that was at 0 stays at 0, so that doesn't move at all. My point that was at pi over 2, so here's my point, it was at pi over 2, I'm going to move it so it fits at pi over 4. Oh, and it would be helpful to show us where pi over 4 is. So pi over 4 is right here, and then we'll need 3 pi over 4 as well, I believe. Okay. Try that again. So our point that was at pi over 2 is now going to moved over, so it's at pi over 4 now. Notice I didn't change the height or anything, but I'm literally just taking that point and I'm moving it over so it's at pi over 4. My point that was at pi now gets moved to pi over 2, so this goes right here, right? I took that point and I just shifted it over, so it's at pi over 2 now. My point that was at 3 pi over 2 gets shifted over, so it's at 3 pi over 4. So I took that point and moved it over. And then last but not least, my point that was at 2 pi will now be at pi. And then this is my period change. So this is when I took my graph and I changed the period of it. So now instead of one wavelength fitting between 0 and 2 pi, one wavelength fits between 0 and pi. It still follows the same shape, right? It goes up, then down, and then back to the middle. This one goes up, then down, then back to the middle. So there we go. And so that's the period change. And so the last thing we have to apply is the amplitude change as well. So I'm going to go ahead and our amplitude change is going to take whatever my graph is and it's going to stretch it so the top goes up and the bottom goes down. You can think of it as multiplying each of your y values by 2. So instead of only stretching up to 1 and down to -1, my highest most point is going to stretch up to 2 and my lowest most point will stretch down to -2 instead. So my 0 will stay at 0 because that's on the midline. Nothing changes about that. My highest point stretches up to 2. My midline stays right there. My lowest point stretches down to -2. And my midline stays right there. So this is where I took the graph where I'd already applied my period change. And then now I've also applied my amplitude change. Oh, it's not super pretty. Let's try again. There we go. And so then now, because I have changed the amplitude, check, changed period, check, this is my final graph, the one in blue. Awesome. All right, we're going to go ahead and try another example. So in this next example, it says find the amplitude and period of this function. So we got a nice cosine graph. That we'll start off with, and we'll find its amplitude, period, and then we're going to sketch it. So let's go ahead and do the amplitude first. Remember that the number that is out front, multiplying your cosine, that is how we change our amplitude. Sorry, I'm just checking for being consistent with my colors. So instead of going up to 4 and down to -4, our graph will go, or excuse me, instead of going up to 1 and down to -1, our cosine graph will go up to 4 and down to -4. And then this one's a weird number. We haven't dealt with a fraction yet, but you still use the same application, right? My normal period is 2 pi, and so I still need to divide it by this number, so 2 pi over 1/3. I have a fraction inside of a fraction, so I take my bottom part, and I flip it, and I multiply it instead. When I flip 1/3, it becomes 3 over 1. And so then when I multiply 2 pi times 3 over 1, I end up with 6 pi instead. And so this is something we haven't seen before. Our amplitude change, as we know, this will be a cosine graph, so our normal cosine graph goes up from -1 to +1. It's going to stretch it so it goes up higher and lower because I'm stretching my amplitude, so it's at 4, -4 instead. But this period change, instead of normally shifting our period so it fits between 0 and 2 pi, which here's our normal cosine graph. What it's going to do instead is we're going to have to extend this axis, and it's going to stretch it out so it fits. It's a wider graph now. It's going to fit between 0. It's going to be like 3 times as wide. It's going to fit between 0 and 6 pi instead. So in our previous problem, we took our original sine function and we shrunk its period, right? We made its period smaller. But in this one, we're actually going to stretch out the graph and make the period larger instead. So that'll be a new part of this. Let's go ahead and do our table first, and then we'll sketch everything. When we do this, right, technically what I'm going to be doing for each of these x-coordinates is dividing by 1/3, but I already know that that will produce so many fractions inside of fractions. Like if I tried to do 0 divided by 1/3, automatically I have a fraction inside of a fraction. So I'm actually going to kind of make myself a little note or something like that and say dividing by 1/3 is the same as multiplying. Oh, maybe I should put no, I wanted to use a dot. Multiplying by 3. So, because that's what I did here, right? I divided by 1/3 or I multiplied by 3. So instead of having to take each of these things and do a lot of flipping and multiplying with each one, I'm just going to automatically divide them all by, multiply them all by 3. So 0 times 3, oops, will still give me 0. Pi over 2 times 3 will give me 3 pi over 2. Pi times 3 will give me 3 pi. 3 pi over 2 times 3 will give me 9 pi over 2. And then 2 pi times 3 will give me 6 pi. And again, you can double check and make sure you did it right if your last piece matches what you got up here. Okay. I think I'm actually going to go ahead and pause here. We can pick this up in the next video because I'm afraid I won't finish the graph by the time this recording limit is done. So go ahead and pause here, take a little break, and then we're going to go ahead and sketch the graph in the next video.